Now we're going to add and subtract rational expressions rather than multiply and divide them. And it's the same rules as for ordinary fractions. If the denominators are equal, then you add and subtract by adding and subtracting the numerators. A over d plus b over d is a plus b over d. A over d minus b over d is a minus b over d. Common denominators. So we do some examples. 8 over 3x plus 5 over 3x. Well, we just add the numerators, 8 plus 5 over the denominator 3x. That's 13 over 3x for that one. Here we have 3x over x squared minus 9 minus 9 over x squared plus 9 minus 9. Common denominator, it's inherited. And the numerator is 3x minus y. Now we can go a little further. 3x minus y is remove a factor of 3 times an x minus 3. The difference of squares in the denominator becomes x minus 3 times x plus 3. And now the x minus 3s are in common, they cancel, and we're left with 3 over x plus 3. Now here they throw a little bit of trickiness. 5x over x minus 3 plus 4x over 3 minus x. Now x minus 3 and 3 minus x are differences written in opposite order. And if you reverse the order of a subtraction, you get the opposite. A minus b is the opposite of b minus a. So you can write this 3 minus x as the opposite of x minus 3. I put the negative sign in the numerator. So it's 4x over 3 minus x is negative 4x over x minus 3. Now we have a common denominator, put it there. Add the numerators, 5x plus negative 4x. So you get x over x minus 3. Here's something I call the rabbit rule, where we have a fraction plus another fraction with different denominators, or fraction minus fraction. It's AD plus BC over BD. Here it's AD minus BC over BD. Both of them have this kind of crisscross pattern like that. Crisscross pattern. Years ago, I asked someone for a good name, one of my students, for a good name for this rule. I mean, what does this shape remind you of? And is it a TP? Is it a television with antennas? Although TVs with TV antennas is so, oh boy, that really dates me to the 20th century. But okay, someone said rabbit rule, which is, I suppose, kind of cute because here are the little rabbit ears. But also it's alliterative rabbit rule, and that's always helpful in remembering things. So that's the name I've given this rule. So 3 over x plus 2 plus 5 over x minus 4. Rabbit rule, 3 times x plus 4 plus 5 times x plus 2 over the product, x plus 2, x minus 4. Now this, we expand and redistribute. 3 times x, 3 times 4 is minus 12, 5x here, 5 times 2 is 10. Combine like terms, 3x plus 5x is 8x, minus 12 plus 10 is minus 2. So 8x minus 2 times x plus 2 times x minus 4. Here we have n plus 2 over n minus 4 minus n plus 5 over n plus 4. Okay, rabbit rule. N plus 2 times n plus 4 here, minus n minus 4 times n plus 5 here, over the product, n minus 4 times n plus 4. And okay, we expand this, n squared plus 2n plus 4n plus 8, minus, now let's be a little careful, minus the whole thing. So n minus 4 times n plus 5 is n squared plus 5n minus 4n minus 20. You have to be careful about doing subtraction, right? And after a bunch of steps, which I skip, it's 5n plus 28 in the numerator over n minus 4 times n plus 4. Now, sometimes you can save some steps, or at least some heavy arithmetic, by using what are called the lowest common multiple. The lowest common multiple, called LCM, of two numbers is the smallest number that's a multiple of both. People confuse that with the greatest common factor, GCF, which is the biggest number that's a factor of both. So for example, 6 and 15. 6 goes into 30 5 times, 15 goes into 30 twice, and no smaller number do both of these go into. So this is the LCM, lowest common multiple of 6 and 15. As for 6 and 15, 3 goes into 6 and 3 goes into 15, and no bigger number goes into both of them. So it's the GCF of 6 and 15. People get them confused because when they say lowest, they think, oh, it must be smaller. So 3, greatest. Oh, it must be bigger. So 30. Wrong, exactly backwards. The lowest, least common multiple is bigger than both, and the greatest common factor is smaller than both. It's a common fact. So this is a common multiple, and therefore bigger than both. And this is a common factor, therefore smaller than both. So, all right. Now, this also works not just for numbers, 6 and 15, but also for algebraic expressions. The LCM of x plus 2 times x plus 3 with x plus 2 times x minus 5 is the simplest expression that both of these go into. It needs a factor of x plus 2. It needs a factor of x plus 3. It already has a factor of x plus 2, so we don't do it twice. But it needs this x minus 5 factor. Here you go, x plus 2, x plus 3, x minus 5. The GCF is the most complicated expression, which goes into both of these. Here's an x plus 2, there it is. And none others are needed, so there that is. That's the second. 6, 3, 3, second parent. All right. 3, 4. All right. Now here, if we add two fractions or rational expressions, instead of putting the product in the denominator, the denominator as they did in the rabbit rule, we'll put the least common multiple. And then we do this complicated thing here where we divide the least common multiple by B for A. We divide the least common multiple by D for C. I call these compensators. They compensate for the bigger new denominator. I don't have any good names for it. I call it the least common denominator rule, which is the same as the least common multiple. So for example, m over m squared plus 9m minus 20 minus 4 over m squared plus 7m plus 12. Okay, first thing to do is to factor both of these denominators. This is m over m plus 5, m plus 4, minus 4 over, and this factors into m plus 3, m plus 4. So, okay, we have denominators n plus 5, m plus 4, and m plus 3, m plus 4. We want the simplest expression that they both go into. It'll need an m plus 4, there it is. It needs an m plus 3, there it is. It needs an m plus 5, and this is all that you need. Now, here's what we do. We have an m here times its compensator minus a 4 here times its compensator. If m plus 5, m plus 4 here, it goes into this new denominator, m plus 5, m plus 3, m plus 4, by a factor of m plus 3. So that's what we put, m times m plus 3. Minus 4 times, now this had the denominators, m plus 3, m plus 4. This is m plus 5, m plus 4, m plus 3, m plus 4. These are, so this divided into this leaves a factor of m plus 5, which is what we put here. Okay, now here you have this expression, which after a certain amount of algebra, which I'm not going to bother, comes out to m squared minus m minus 20. That factors into m plus minus 5 times m plus 4. M plus 4 is canceled, and we're left with m minus 5 times m plus 5, m plus 3. Like that. You have three fractions. Fortunately, this denominator is the least common, is actually a multiple of both. 3 over 2x plus 1 plus x plus 1 over 3x plus 2 minus, or plus a negative, 2 over 6x squared plus x minus 2. Now this, after a certain amount of the usual AC stuff, is 2x minus 1 times 3x plus 2. And lo and behold, here's 2x plus 1, and here's a 3x plus 2 already. So this 2x minus 1 times 3x plus 2 is already the lowest common denominator. Now this divided into this leaves a 3x plus 2. So here's a 3x plus 2 compensator times the 3x plus x plus 1 times this goes into this with this as a ratio. So we can put 2x minus 1 as the compensator. And this are the same, so the compensator is 1 and times the negative 2. Okay, 3x times 3x plus 2 times x plus 1 times 2x minus 1 plus twice negative 1. And then after a certain amount of algebra, we get 11x squared plus 7x minus 3 over 2x minus 1 times 3x plus 2. And that's this. All right, more examples. Oh, did we do this before? I did do this before. Oh dear. Okay, I did this one before. This I already did before. I'm surprised I'm doing all this. Okay, here, 3 over x plus 2 plus 5 over x minus 4. Do the rabbit rule. 3 times x plus 4 plus 5 times x minus 2. After some distributing, you get 3x minus 12 from this, plus 5x plus 10 from this. And yeah, that's 8x minus 2 over x plus 2x minus 4. And yes, I did do that one before. Oh, well. I hope I'm not trying to avoid further repetitions. Okay, this is not the same. A minus 1 over a plus 4 plus a plus 3 over a minus 5. Use the rabbit rule. A plus 1, a minus 3 here, plus a plus 4, a plus 3 here over the product, a plus 4, a minus 5. Okay, this expands out to some terms, this expands out to some terms, and after adding up all the terms, you get this, 2a squared plus a plus 17 over a plus 4 times a minus 5. You have n plus 2 over n minus 4 minus and n plus 5 over n plus 4. Rabbit rule, n plus 2 times n plus 4 minus n minus 4 times n plus 5 here over the product n minus 4 times n plus 4. Okay, this expands out to 4 terms, n squared plus 4n plus 2n minus 8. Here you have to be a little careful because there's a minus sign. So really the step I skipped where we expanded this and flipped all the signs. To get minus n times n is minus n squared, minus n times 5 is minus 5n, minus negative 4 times n is plus 4n, minus negative 4 times 5 is plus 20. So you have all this, and n squareds cancel. 4n plus 2n minus 5n plus 4n makes 5n, and 8 plus 20 makes 28. So 5n plus 28 over n minus 4n plus 4. All right. M over m squared plus 9m plus 20 minus 4 over m squared plus 7m plus 12. This denominator, m squared plus 9m plus 20, factors this into m plus 4 times m plus 5. This denominator, m squared plus 7m plus 12, factors into m plus 3 times m plus 4. Now, again, we want the least common denominator. So it needs an m plus 4. 1 is sufficient. There it goes. It needs an n plus 5. Put that there. And it needs an n plus 3. Put that there. This is a multiple of both of these. And the smallest one. M plus 4, m plus 5 into all this leaves a factor of m plus 3. So here's m plus 3 as a compensator times m minus 4 times its compensator. M plus 3, m plus 4 into all this leaves an m plus 5. So minus 4 times n plus 5. Mn plus 3 minus 4 times n plus 5. Distribute m squared plus 3m here minus 4m minus 20 here. Combine these terms. M squared minus m minus 20. And then after a bit of factoring, that comes out to m minus 5 times n plus 4. That over m plus 4, m plus 5, m plus 3. The m plus 4 is canceled, and we're left with m minus 5 times m plus 5 times m plus 3. Okay, we did this one already. 5x over x minus 3 plus 4x over 3 minus x. This 3 minus x you reverse. Oh dear, this should be a x minus 3. Let me change that. 6, 3, 8. 59, 4x minus 4x over x minus 3. Okay, so 5x minus 4x over x minus 3, x over x minus 3. Did this before and I made a mistake here. Oh well. Number 8. Number 9. Did I do this one before? Hold on a second. This looks vaguely familiar.
Yes.
Okay. Redundancies. Maybe I should edit this thoroughly. All right, fine. So yeah, same deal. We had this was a multiple of both of these, so this was really the least common denominator, and we proceed from there. Let's see if let's hope I didn't mess up this one. And B. Okay, this I did not redo, so here we go. And again, this is a lookalike problems. Here we add two rational expressions. Here we multiply them. Okay, here we do rabbit rule, x1 plus minus 1 times x minus 1 plus x plus 2 over x plus 2 times x minus 1. Okay, this expands out to x squared minus 2x plus 1. This expands out to x squared plus 4x plus 4. So add them up, 2x squared here minus 2x plus 4x is plus 2x, 1 plus 4 makes 5. Over the denominator, x plus 2 times x minus 1. Now here, multiplying them, it's made easier by the fact that x minus 1's cancel, x plus 2's cancel, leaving only 1. Now there are several problems in here, in this problem section, where you have this horribly complicated multiplication or division, and everything cancels out and leaves a 1. And I think they deliberately threw that in just to make you scared. It couldn't be that simple, could it? Well, in a couple of cases, it is that simple. You just have to go ahead and make sure you got it right. In a couple other cases, it's not that simple, so be advised. All right, we proceed. Okay, I think that's it for today. Stop recording.